Okay, so I know that we didn't get to very many things to do with magnification today, so I wanted to go over a couple of things. So first of all, you can see there's a couple of different formulas, and there's one more I'm going to give you. So magnification equals the measured length over the scale bar label, and then the actual size equaled the measured length over magnification. And let me give you one additional, and that is, it's just a slightly different way of saying the exact same thing. And that is magnification equals drawing size divided by actual size. All of these basically say the same thing. And just to remember that when you're converting between metric units, you have base, which is meters, liters, and grams, deci, centi, milli, micro, nano, right? And if you want to say convert 6 centimeters into micrometers, you start with centi, and you count places 1, 2, 3, 4. Okay, so you move your decimal place 4 places, 1, 2, 3, 4. Okay, I also want to remind you that micro sometimes is written like this with a U, depending on how lazy I was being when I made this. Okay, so my table is not present, unfortunately, which is kind of ridiculous, but specimen size, drawing size, magnification. So based on this formula, you should be able to sort out how to do this. I do want to mention that your units all need to be the same if you're plugging them into the same formula. So you're going to have to convert some units in order to be able to do this. So why don't we do one together? So we'll do the first one together. Actual specimen size, and then we want to find the magnification. So magnification, the actual specimen size goes below 0.5 millimeters. And then we have 2 centimeters. Remember, we need to convert it. So just a reminder, you can just go 1 decimal place and it becomes millimeters, 20 millimeters, right? Which gives us 40x. And you can see the units cancel out. X is what you put after a magnification. Okay, so you should be able to do the rest of these on your own. So if you go back in here, this one is going to allow you to do that. Now, I don't have a ruler on here as far as I know. I don't think I have a ruler. All right, so when you're looking at these, what you need to do, you're calculating the magnification of these scale bars. So you've been given a scale bar and you've been given the actual amount that represents. But basically, you would measure this length with an actual ruler, and I kind of made a mistake there. Let me fix that. You're going to measure that actual length with a ruler, and then you need to convert it into micrometers, and then you're going to use the formula and this number to get the magnification, okay? And you're going to do the exact same thing with all of these. They're giving you the magnification, and you have the actual size, these yellow lines, and you just need to measure those. You don't have the actual size, you have the scale bar size, so then you need to measure those with a ruler. And that should be able to give you the actual size. Okay, so here, again, they've given you your scale bar, and they've given you this, so why don't we work it out? Okay, so let's use this as an example. Now, I don't have a ruler, so I've measured it on my piece of paper, and I'm guessing it would be about the same as yours, but I've measured this line, and it was 7.3 centimeters. Now, yours might be different depending on how the printout went. And then I've also measured this line, which was 1.8 centimeters. Okay, now this is actually super easy to sort out. What I want to know is the length of the stomata, which actually you guys saw stomata under the microscope. All it is 7.3 centimeters divided by 1.8 centimeters equals, that's 4.06. And right now it doesn't have a unit because we've crossed out the units. And then all we have to do is multiply it by 20 micrometers. And that gives us 81.2 micrometers. Okay, so with these, it's more a matter of common sense than anything else, okay? Okay, so for this one, let's do A first. So A is the length of this epithelial cell, so the yellow part. So when I measured it before, I got 8 centimeters. You may have slightly different depending on how I printed it. And then I also measured this, and I got 2.8 centimeters. Okay, so when you're calculating this, it's actually pretty easy. It's just 8 centimeters divided by 2.8 centimeters, which equals 2.86. Notice the centimeters cancel out, times 10 micrometers, which equals 28.6 micrometers. Okay, so that's the actual length of the epithelial cell. For B, that's the nucleus. So I did like from here to here. Nucleus is not exactly round, so, you know, work it out. It's okay. So this is about 2.8 centimeters. 2.8 centimeters divided by 2.8 centimeters equals 1 times 10 to the micrometer equals 10 micrometer nucleus. All right, so this is an egg. Calculate the diameter of the main body of this human egg and the thickness of one section of the zona pellucida. Okay, so when you're doing the egg, and I got 3.4 in my measurements, centimeters. So let's do the egg first. So 3.4 centimeters divided by 1.4 centimeters equals 2.4, 3 times 40 micrometers down here. Oh, incidentally, this was 1.4, sorry. 40 micrometers. Oof, I'm being very messy. Let me just erase some stuff. Make it a little tidier. Which equals 97.2 micrometers. B is this zona pellucida. Okay, so for this one, I measured the zona pellucida like here. You're going to get different measurements depending on where you did it. So it's 1.7 centimeters. So same idea, 1.7 centimeters divided by 1.4 centimeters, 1.21 times 40. Okay. Okay, so one more thing. This is data that I expected you guys to measure, and then we don't have the way of measuring it. So the field of view at 4x is low power field, and it's 4.4 millimeters. So what I'm saying is at 4x, when you look down the microscope, the diameter is 4.4 millimeters. At 10x, the diameter is, I'm looking to see what it is 1.7 millimeters. And then at high power, which is 40x, it is 0.4 millimeters. Okay, and then the other thing is total magnification. So it's 4 times 10, because that's the optic lens. So we get 40x times 10 is 100x times 10 is 400x. Okay, so the rest of the questions on here, when they ask you for Melodia, there we go, it's on the second page. Okay, so I measured from here to here. I'm going to switch colors. Just like this. I measured that guy, and I got 11 centimeters. Again, it could depend on your actual printout. So 11 centimeters divided by 2.4 centimeters equals 4.85. 0.85 times 10 micrometers, 45.8 micrometers. Okay, so a student views an image of a cell magnified 5,000 times. The image is 60 millimeters long. Okay, so the image divided by, this is magic triangle, magnification, and then the actual sample length. So it's going to be 60,000 micrometers divided by 50,000 times equals 1.2 micrometers. Okay, so the cell it's very small, so it's going to be a virus probably, because it's very small. Okay, a sperm cell has a tail the length of 50 micrometers. A student draws it 50 millimeters long. What is its magnification? So magnification, 50,000. Oh, yeah, because this is 50,000 micrometers. You have to convert it, divided by 50, which gives you 1,000x. Okay. The table, it's this one. Okay, so so I didn't give you a field of view. 4 cells, so let's do it anyways. So the 4 cells, like say this, 1, 2, 3, 4. Diameter of your high power field. So for this one, I gave it to you actually at 0.4 millimeters, which is 400 micrometers. Okay, approximately how long is each cell? So 400 micrometers divided by 4 cells. So each one is approximately 100 micrometers long. Okay. All right, so you're going to estimate the size. So the bug stretches halfway across. So 4.4, and this is low power, 4.4 millimeters divided in half equals 2.2 millimeters. A cell stretches a quarter of the way at medium power field, 1.7 millimeters divided by 4, 0.4 millimeters. 20 cells, I'm not going to actually draw those, sorry. High power, 0.4 millimeters divided by 20, 0.02 millimeters, or 20 micrometers. 15 plant cells, medium power, so 1.7 millimeters divided by 15 cells, 0.113 millimeters. 5 micro bugs fit across the low power fields, so 4.4 micrometers divided by 5. Okay. Half a worm, low power, so it's going to be 4.4 millimeters divided by 2.2 millimeters. Okay, so for number 11, this means it's half magnification, so it's basically half as big as it really is. Because 1 is like normal, right? And then half, you're making it smaller. Okay, so low power field, and it stretches 3/4 of the way across. What is its approximate length? What is the magnification if you drew it 10 centimeters long? Okay, so low power field, the whole thing is 4.4. So I actually haven't done this math yet. Divide that by 4 times, so it's 1.1. for every quarter, and it goes 3/4, so it's 3.3 millimeters long. Okay, for the second part of this, you can use, actually you don't even need a pyramid for this, make your life easy. Magnification equals drawing size over image size. Okay, so for this, drawing size would be 10 centimeters up here, and then 3.3 millimeters. Obviously you cannot leave this as it is, so it's 100 millimeters, and then 3.3. And I don't actually have a calculator with me, but divide those, and there's your answer. Some of these using this